as we often do in CS70, we'll start with some definitions. My first definition for you is a random experiment. That is drawing k samples from a set S with cardinality n. So for example, imagine we are thinking about rolling 4-sided dice, 2 of them in particular. In this case, our set of possible outcomes is a 1, a 2, a 3, or a 4. Our cardinality is 4, and I'm rolling k equals 2 dice. In this particular case, we see that someone rolled 2 2s. I don't know if you've ever seen one of these dice. They're little tetrahedrons. The number that comes up right side up, that's going to be the number you get. So in this case, we got 2 2s, and that's what we call a sample point. That's an outcome of a single experiment from this framework of a random experiment. Now, of course, there are more than just this single outcome that could happen. There are 16 possible outcomes. And all of those outcomes comprise what's known as our sample space. Those sample points comprise the sample space. Okay? So here, capital omega is the symbol we often use to represent this sample space. Here it's small enough we can write them all out explicitly. There they are. That's the first pillar that we're going to be building all of our discrete probability upon. Okay? Then we have the other big piece, the other pillar, which is the probability function. So if you take a sample space and you associate each of the sample points in that space with a probability, then you get what's called a probability space. So it's sample space plus a function. What are the properties of that function? Well, it takes a sample point, often denoted with a lowercase omega, and it maps it to a real number between 0 and 1. And then when you add up all of the probabilities, they should, of course, be 1. And this should make some intuitive sense. Now, in this particular case, where we are rolling 2 fair 4-sided dice, we end up with what's called a uniform probability space because all of the outcomes have the same probability, 1/16. One more piece of terminology before we start doing some slightly more interesting exercises is the probability of an event, or the term is an event. So what is an event? Well, an event is just any subset of the sample space. Okay, this is an intuitively useful notion, like what's the chance that the dice sum to at least 7? Or what's the chance that if I throw a ball, it will land in that particular trash can out of 5 trash cans, something like that. Okay? So this notion of an event, if we want to know the probability of an event, all we do is add up the probabilities, the sample points in the sample space that are in the event. Okay? So as an example, was the second roll greater than the first roll? Well, we just have to figure out which outcomes go with that. So there's 6 of them, right? There's 1, 2. So if that second roll is bigger than the first, that's, we see 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4. These particular sample points, we just add up their probabilities and we get, in this particular case, 6/16, which is 3/8. So from there, we have our basic definitions. So now let's play around with them a little, solve some more interesting problems.